A warship as long as the Empire State Building is tall, the USS Gerald R. Ford shattered every record when it joined the U.S. Navy at over 100,000 tons. But why did America build the most extreme and arguably most absurd aircraft carrier ever imagined? The answer is not just about power, but a new kind of naval pressure you have not seen before. What drove the Navy to this outrageous brink? Steel and ambition stretch farther than the eye can see. The USS Gerald R. Ford stands at 1,106 feet in length, longer than 3 football fields end to end. Its flight deck alone spans 256 feet across, wider than 8 city buses parked side by side. Beneath the surface, the ship's full load displacement pushes the scale to nearly 100,000 tons, outclassing every warship that came before it. That is more mass than the largest cruise liners ever built, more than the weight of 100 fully loaded Boeing 747s. Rising from the waterline, the Ford structure packs in 25 vertical decks, a labyrinth of steel stretching from the hull's depths to the top of its superstructure. Each level supports a slice of what amounts to a floating metropolis. At any given moment, between 4,500 and 5,000 people live and work on board, a population greater than many small towns. The ship's internal systems churn out 400,000 gallons of fresh water every day, enough to supply a city block, while its nuclear heart propels it through the ocean for more than 2 decades without a single refuel. Every statistic defies comparison. More steel than several skyscrapers, a flight deck large enough to launch dozens of aircraft simultaneously, and a sheer presence that dwarfs anything else afloat. The numbers do not just add up, they overwhelm. This is the point where naval scale stops making sense and starts bending the limits of what a ship can be. By the late 1990s, the Navy faced a problem that sheer size alone could not solve. Decades of non-stop deployments had stretched crews thin and worn down ships faster than ever before. Carriers no longer just prepared for major battles. They became fixtures off distant coastlines, standing watch in hot zones for months at a time. The pace was relentless. Crews cycled through exhausting rotations, and maintenance teams struggled to keep up with the demands of constant readiness. Each deployment meant less time for repairs, more pressure on sailors, and rising costs to keep aging ships afloat. At the same time, the nature of conflict had changed. Instead of meeting rival fleets head-on, carriers found themselves responding to unpredictable threats, missile attacks from hidden launchers, fast-moving boats, and drones that could strike with little warning. The lesson was clear. Presence mattered as much as firepower. A carrier that could stay on station longer, with fewer resupply breaks and less crew turnover, became a strategic asset in a world defined by uncertainty. Budget realities forced a choice. Building more carriers was out of reach, so the Navy doubled down on making each ship count for more. They prioritized quality over quantity, betting that a single, more capable ship could do the work of several older ones. This decision set the stage for a new kind of engineering, a leap not just in size, but in endurance, automation, and adaptability. The result would be a warship built to withstand the grind of modern conflict, able to project power and stay in the fight long after others had to head home. Deep inside the hull, the USS Gerald R. Ford draws its strength from a pair of A-1B nuclear reactors, machines engineered not just for propulsion, but for raw, untapped energy. Each reactor is more powerful than anything found on the Nimitz class, together producing more than 100 megawatts of electricity. That is enough to power a small city, or to keep the Ford running at over 30 knots despite weighing nearly 100,000 tons. The numbers are staggering. With these reactors, the ship can circle the globe for 25 years without refueling. No oil tankers, no supply convoys, no need to break off patrol for a pit stop. This surplus of power is not just about speed or range. It is a strategic reserve, a well of electricity that future-proofs the ship for decades. Every radar sweep, every launch from the flight deck, every advanced system draws from this endless current. The engineering crew below decks manage a power grid that can handle today's demands and whatever tomorrow's weapons, sensors, or drones might require. On the Gerald R. Ford, energy is less a constraint than a resource waiting to be used. On the Gerald R. Ford, the flight deck looks almost empty compared to older carriers. That emptiness is by design. The island, the ship's command tower, sits farther back and is smaller than ever before, opening up an uninterrupted stretch of deck space. With more room to maneuver, aircraft handlers can launch and recover jets with fewer bottlenecks and less risk of collisions. The elevator system, once a tangle of 4 bulky lifts, now relies on 3 streamlined, high-speed elevators. Each one is positioned for direct access to the hangar and weapons magazines, cutting the time it takes to bring up bombs and move aircraft into position. Automation plays a silent but crucial role, trimming the number of deck crew needed to keep operations running smoothly. The result is striking. Ford can launch about 25% more sorties per day than the Nimitz class, even with a smaller flight deck team. For the sailors working the deck, it means less chaos, fewer close calls, and a faster pace that keeps the air wing in the fight longer and with fewer delays. Steam catapults once ruled the flight decks of every American carrier, but the Ford's designers gambled on something entirely new: electricity instead of brute force. The electromagnetic aircraft launch system, EMALS, uses powerful bursts of electromagnetic energy to hurl jets off the deck. Instead of a violent jolt, pilots describe a smooth, almost eerie acceleration, with no more bone-rattling shock at launch. This precision means less wear on every airframe, and it opens the door to launching aircraft that steam could never handle, lighter unmanned drones, heavier strike jets, and even future platforms not yet imagined. The Advanced Arresting Gear, AAG, brings the same finesse to landings, using electromagnetic motors to slow incoming planes with a softer, more controlled pull. On July 28, 2017, test pilot Commander Jamie Struck made history as the first to launch from a carrier using EMALS, calling it a new chapter in naval aviation. Engineers and deck crews watched as decades of tradition gave way to technology that promised more launches, fewer breakdowns, and a future built on adaptability rather than old limits. The price of ambition came due in dollars and delays. The USS Gerald R. Ford's construction cost soared to nearly $13 billion, making it the most expensive warship ever built. Oversight committees and watchdog agencies questioned every line item as new technologies pushed budgets far beyond early estimates. The advanced weapons elevators, designed to move bombs and missiles faster than ever, became a flashpoint. Persistent software glitches and hardware failures meant that years after commissioning, some elevators still weren't operational. Testing setbacks piled up. In the summer of 2021, the ship underwent full ship shock trials. Massive underwater explosions meant to prove the hull's resilience. Each blast rattled systems and nerves alike, but the Ford held together under pressure. Every delay and cost overrun fueled debate. Was this leap in capability worth the risk and the price? The answer would shape not just the ship, but the future of naval warfare. Inside the USS Gerald R. Ford, daily life unfolds on a scale that borders on the surreal. Up to 5,000 people eat, sleep, and work in a maze of corridors and compartments, each one a part of a self-contained town adrift in the ocean. The ship's water plant produces 400,000 gallons every day, enough to keep every sailor hydrated, every kitchen running, and every shower flowing for weeks at sea. Getting around isn't a matter of a few steps. Electric carts and bicycles are a necessity just to cross from bow to stern. The distances are so great, a trip to the galley or the gym can feel like a trek across a city. But there is a hard edge to this grandeur. No port in the world can handle anything larger, and every extra ton concentrates more risk in a single hull. At 100,000 tons, the Ford class sits at the absolute ceiling. Beyond this, size becomes a liability, not an advantage. Today, one ship contains the firepower, infrastructure, and ambition of a nation. As technology shrinks the world, the limits of scale become limits of imagination. The real question now, how much power should ever rest in a single floating city? Thanks for watching. Share your thoughts below.